Ladies, we are in Chapter 3, Section 1. We're studying exponential functions, and we are looking at Goal 4. Goal 4, we're going to use exponential functions to model and solve real-life problems. And right now we're going to talk about compound interest. We're going to talk about it in terms of this example. You're going to take $2,000 and it's put into a savings account that earns 3% interest for 5 years. And I want to know, what does that yield? In other words, how much money is in your account after 5 years when you compound the interest annually, semi-annually, quarterly, monthly, and daily? And by compound, I mean calculate the interest. Annually means you would calculate the interest 1 time per year. Semi-annually, 2 times per year. Quarterly, 4 times per year. Monthly, 12 times per year. And daily, 365 days per year. To determine this, we are going to use this equation, this formula, which allows us to calculate compound interest. I will always give you this formula on quizzes and tests. So you do not have to memorize it, but it's important that you practice using it. Let's talk about what each of these values represent. Let's begin with A. A represents the amount in the account at the end of the number of years that you are compounding the interest. So at the end of the investment, you might refer to that as the word balance. So it is the balance in the investment. Okay. A sub 0 represents the principal amount. So you might see some formulas that substitute the capital letter P in the place of A sub 0, and that would be fine if you did that. Now, principal represents this little A sub 0. Anytime you see sub 0, that means initial or beginning amount. So the principal amount is the amount invested, or the initial amount. Let's talk about R. R would represent the interest rate. Interest rate is always given as a percentage. So it's important to remember that when you plug the interest rate into the formula, you change it from the percentage to a decimal. And even if it's 3.1%, you still have to eliminate the percentage symbol. I just completely lost my train of thought. Sorry. Remember to do that. You divide by 100, which is equivalent to moving the decimal 2 places to the left. N is an important variable in this equation. It represents the number of compounding periods per year. That's why when I went through A, B, C, D, and E, I said that we compound annually, compound 1 time per year. So in this case, N is equal to 1. I want you to stop right now and go through A, B, C, D, and E and write down the value of N for each of those now, please. If you did, you might have done it when I went through them the first time, but now you know that they represent N. So annually means we compound 1 time per year. Semi-annually, we compound 2 times. Quarterly, we compound 4. Monthly, we compound 12 times per year. Daily, 365. And there are other compounding periods. We could compound weekly if we wanted. Lastly, T represents time. And time, when we're calculating compound interest, is in years. Okay, what I would like for you to do is to, let's calculate the compound interest annually. So let's go through setting up this formula. It asks what is the yield, or what is the balance. So after compounding annually for 5 years, let's determine our balance. So A is equal to A sub 0, which remember we said is also P, our principal, that's the amount that we put into the account, and that would be $2,000. So this is our initial investment times 1 plus, now our interest rate is 3%. So when we change that to a decimal, we move the decimal 2 places to the left, so the rate is 0.03. Divided by n, the number of compounding periods per year, raised to the n times t power. T is 5 years in this case, and 5 times 1 is 5. Once you have this filled in, you have my permission to use your calculator to calculate the amount or the balance. So I'd like you to pause the screencast and calculate this balance. Okay, I'm going to do this with you just to make sure that you know how to use your calculator to complete this. So 2,000, then 1 plus 0.03, which is 1.03. We don't have to do the division by 1. 0.03 divided by 1 is 0.03. And then all of that is raised to the 5th power. So after 5 years, if we compound annually, our balance is $2,318.55. So $2,318.55. What I'd like for you to do is at this time write out the formula using the information for semi-annually, quarterly, monthly, and daily, and calculate your balance. Once you have completed that, please turn the screencast back on and check your answers. Okay, so quickly check your balance for each compounding period. If your answer does not match mine, go back and check your work. You could have just typed a value incorrectly into your calculator, but the only difference in these, the remaining equations should be your value of n and your value of n times t. Now that you've checked and corrected, I want you to notice what's happening to the balance as we compound more frequently. When we compound annually to semi-annually, we increase by about $3. Semi-annually to quarterly, we increase by about $1. Quarterly to monthly, we increase a little less than $1. And monthly to daily, we increase by 42 cents.